Hello everyone, welcome back to Deeksha Karnataka YouTube channel, and today I am going to discuss a very important topic for all of you, those who are currently studying in the second PU, right? So I am going to discuss how can you master physics in upcoming next 30 days so that you can score 70 out of 70 in your half yearly exam. So your half yearly exam is at doorstep. So if you are thinking that I will start studying in the day before exam or the night before exam, definitely you are not going to do well. So you have to start now, and physics is being one of the most difficult subjects. I am going to tell you what are all the important topics, important chapters, etc., and how can you score well in your upcoming half yearly exam. It will be a 70 marks exam, and most of you will be going to give exam based on the paper set by your respective district boards. It is not the main board, but district board also sets question paper for your half yearly exam as well as for your pre-board exam. So those two exams are generally question paper comes from your board. Some colleges do prefer by taking exams on their own set of question papers, but most of you will be giving exam based on the district board paper, right? So let us start with what you are going to get from this video. So understanding the physics question paper, so you have to understand the paper pattern, so that I am going to discuss here. We will also discuss half yearly chapter wise weightage. So what is the chapter wise weightage of each of the chapters, 1 month study plan as well, so how you can finish all the chapters. Then we will have best resources from where you should study and tips to success. So these are the main topics that we are going to discuss. Let us start with the understanding the question paper. So those who have appeared in the PU1 exam, the paper pattern varies from subject to subject. So here is the physics question paper pattern. You will be required to answer 15 MCQs, 15 questions will be asked, and you have to answer all of the 15 questions, and 15 marks is allocated for that. Some students feel that this is one of the most difficult part, but trust me, if you study properly, this can be a very scoring part of your exam. Next, there will be 5 fill in the blanks. So fill in the blanks also some students feel it difficult, but it is not that difficult if you study properly. Next, there will be short answer type 2 marker questions. 8 questions will be asked in this section, but you only need to answer 5 of them, and 10 marks is allocated for this 2 marker section. Next, there are 3 marker questions. So in 3 marker again 8 questions will be asked. You need to answer 5 of them, and 15 marks is allocated for that. Long answer type question, 5 questions will be asked, 3 questions you have to answer, 15 marks is allocated for that. And in the numerical sections, 4 questions will be asked, 2 questions you need to answer, and 10 marks is allocated for the numerical section. So total questions will be 45. You need to answer only 30 of them, and the marks that you need to score is 70. So set your priorities properly so that you don't miss out on any of the question section, right? Next is, let us discuss chapter wise weightage of each of the chapter. So here electric charges and fields are one of the most important chapter. It is a very high weightage chapter, and from this chapter numerical questions, there is a high probability that there will be a numerical question will come from this chapter. So you have to practice numericals from this chapter, without any miss. Now, what are all the important concepts from this chapter? Coulomb's law, properties of charge, properties of electric field lines, torque on an electric dipole, Gauss's law, they are all important concepts. Application part, application means where you might be required to solve numerical questions, or they will ask you some detailed question from this concept. So these are comes under applications. So electric field due to a point charge. So based on that, questions, numerical questions or simple understanding based questions will come. Force on a point charge. What is the force on a point charge? F is equal to Q into E. So based on this, a lot of questions, numerical questions especially, will come from this. Electric field due to a charged dipole, that is also very charged plate, charge plate, that is also very important. Now in the derivation sections also, whatever is the formula that you are deriving, based on that there will be numerical questions. So electric field due to a dipole, two positions, one is on the axis, another one is on the equatorial plane, both are important. Electric field due to a long straight wire, another important concept. Electric field due to a spherical shell, another important concept. So these are the important derivations, and from this also numerical questions may come. Now let's move on to the next chapter, electrostatics of potential and capacitance, another important high weightage chapter. Okay, must practice numericals from this chapter. Okay, you cannot skip the numericals from this chapter. Again, another important chapter in terms of numericals. Now electric potential, equipotential surface, electrostatics of conductors, torque on an electric dipole, polar and non-polar molecules, these are important concepts in terms of applications. Potential energy of a system of charge, capacitors in series and parallel, energy stored in a capacitor, they are important application part. In derivations, relation between electric field and potential, this is a 3-marker derivation. Electric potential due to a point charge, capacitance of a parallel plate capacitor, potential due to a dipole, potential energy of a dipole in an external field. Now potential due to a dipole may not come as a derivation, but there is a possibility that it might come as a numerical question, so you cannot skip that as well. Right, now let's move on to the next chapter, current electricity. This is one of the highest weighted chapter. Okay, one numerical should come from this chapter. Now whether to practice the numerical from this chapter or not, that is up to you. If you feel that current electricity is my strong part, then you can practice numericals, or otherwise you can skip numerical from this chapter. That is my suggestion. I generally do not recommend solving numericals from current electricity for board exams, because the numericals from this chapter are little bit difficult to solve, and lot of students sometimes make mistakes thinking that it is an easy question, and while solving the KCL KVL related questions, student make mistakes. So that's why even though there will be a numerical, definitely a numerical will come from this chapter, but whether to solve it based on your personal experience, if you feel confident that I will be solving this numerical, then you should practice. Otherwise you can skip the numerical from this chapter. Drift velocity, mobility, relaxation time, Ohm's law and its limitation, both are important. Current and current density, electric power, resistivity, these are important concepts from this chapter. In terms of application, resistance of a conductor, R is equal to rho L by A, Kirchhoff's laws, Kirchhoff's current law and voltage laws, energy stored in a capacitor. Sorry, this is I think there is a mistake. This is from the previous chapter. Cells in series and parallel, derivation very important. Wheatstone bridge also very important derivation. In half yearly there is a high chance one derivation will definitely come from this chapter. Moving charges and magnetism, another high weighted chapter. Now in midterm there are sometimes you might get a numerical from this chapter, but there is a chance that 3-marker numerical will come from this chapter, not a 5-marker. Okay, 3-marker will definitely come, 5-marker may come, may not come. Okay, so Lorentz force, motion of a charge in a magnetic field, Biot-Savart's law, galvanometer conversions, ammeter and voltmeter conversion, everything is important from this chapter. Applications, solenoid, circular current carrying loop as a magnetic dipole, Ampere's law, they are important application. In derivations, magnetic field on the axis of a current loop, force between two parallel wires, very important derivation. Torque on a rectangular current loop, this is also a important derivation based on your previous year's model question papers. This is also a part of the derivation section. Magnetism and matter, usually a low weighted chapter. Obviously MCQs and fill in the blanks you have to answer. Otherwise, if you are not you don't get time, you can skip this chapter. Just read it once and don't do a lot of practice from this chapter. This is a low weighted chapter. Properties of magnetic field lines, Gauss's law, properties of magnetic field lines can come as a 3-marker question, so you can practice that because this is easier and almost similar to that of the electric field lines. There are some differences, but almost similar to that of electric field lines. Gauss's law of magnetism, magnetization, magnetic susceptibility, magnetic permeability, they are all important. In application section, the magnetic dipole in a uniform magnetic field, paramagnet, diamagnet and ferromagnet, differences between them, that is also might come as a application based question. Next chapter, electromagnetic induction, medium weighted chapter, not super high, not super low, but it's a medium weighted chapter. Faraday's and Lenz's law of induction, inductances, self and mutual inductances, Faraday's coil magnet experiment, AC generator might come as a application question. Not numerical but application based question. Derivation, motional electromotive force is the 3-marker derivation, and very often it comes, so you have to study them. Alternating current, medium weighted chapter, again not super important, but from this chapter you will expect one numerical question. Now if this chapter is not part of your midterm, then you have to mention that in the comment below what are other chapters that you have in your midterm paper, because some colleges study in a 2-track system and they make their own question paper, so they may not have completed alternating current yet, so that's why it may not be part of your midterm exam. So if you don't have this chapter, as I mentioned, please mention that in the comment section. Concepts, RMS voltage and current, AC power, power factor, they are the important concepts. Application, AC applied to resistor, inductor, capacitor, series LCR, impedance, voltage, phase, current, resonance, they are important applications. Derivations generally do not come from this chapter. Ray optics, this is also a high weighted chapter, very high weighted chapter, so and also one numerical will come from this chapter. So if you practice numericals from the first 2 chapters and AC and ray optics, you should be fine and you should be able to answer 2 numerical questions. 4 chapters you have to practice, and not only for your half yearly, the same 4 chapter you have to practice for your board exams. So if you prepare these 4 chapters numericals right now, it will not only help you to score well in your midterm exam, it will also help you to score well in your final board exams. Okay, now what are the important concepts? Total internal reflection, sign convention, mirror and lenses, telescopes, microscopes, F is equal to R by 2 derivation might come, mirror and lens equations from based on these numerical questions will come, power of a lens, this is also numerical questions. Now in the derivation section, diffraction through a spherical surface, lens maker's formula, very very important derivation, numerical question in terms of numericals also, this is important. Refractive index of prism, angle of minimum deviation, they are also important in terms of derivations. Right, so these are the all important chapters that you are going to have when you are appearing for your midterm. These are the chapters that you have to answer. Now if you have any other chapter, don't forget to mention that in the comment section of the down below, that sir I have this chapter as well, because these chapters we have taken from the most common syllabus that is coming across the district. There are some variations depending upon the districts that you are currently studying, so please don't forget to mention if you have any other chapters. Now here is the day wise breakup, that how many days you need to spend on each chapter. This is the maximum number of days, minimum number of days is 2 for each chapter. Okay, but electric charges and fields, I feel you can complete this chapter in 3 days. Okay, maximum 3 days you can take. You should not take more than these many days. That is very very important. So if you are studying it, study in 3 days. First day you complete NCRT. Okay, next day what you can do, you can revise the concepts and then you can solve the PYQs, or you can practice the NCRT exercise, whatever you are you can do. I suggest PYQs plus numericals from NCRT, that is very very important. Okay, so this is how you should study. Next, electrostatic potential in another 3 days you should spend here. Current electricity 3 days. Moving charges and magnetism 3 days. Magnetism and matter you can finish this chapter in 1 day, but maximum you can take 2 days. Electromagnetic induction you should be able to finish everything in 2 days. Alternating current again 1 day you should study the theory, 1 day you should practice the numericals. Now ray optics, it's little bit bigger chapter, so 4 days you should be able to finish everything from this chapter. Lot of derivations are there, so 4 days you need to practice, and revision plus PYQs you should do for 8 days. Now this is not how you should study. How you should study, you finish one chapter, you do the PYQs. Next you finish the second chapter and do the PYQs. Later on, whenever you are getting some extra time, you can revise the chapter. This is a 30-day plan, so you should invest wisely. You have to study other chapters as well, other subjects as well. So this is a 30-day complete study strategy for your physics. Now based on this you can do a ±1, but not waste too much time on a single chapter. That is very, very important. Okay, you have to finish every chapter possible. Now next is from where you should study. So first is for concepts, obviously your NCERT. There is no other alternative. NCERT should be your first book to study concepts. Also you have to practice the numericals from NCERT textbook. For PYQs you can, I generally prefer Legend Physics of Madan Gopal Publications. There is another publication called Jeevit Publication, that is also very, very good. Any one of the books for studying PYQs, they have given the PYQs in the end of the book. From there you can practice, or you can have another only PYQ book. They have theory plus PYQ. Okay, answers are also given in that section. So if you purchase this book, this will not only give you the PYQs, they say that they also have a theory portions as well. This is a particular PYQ book, chapter wise PYQ and answer. Okay, so this is only for PYQs. You can have this Oswald book, which is also very, very decent book. Now some of the tips from my side, what I want to say is that start with high weighted chapters. So you are aware what are all the high weighted chapters, and you have to study them first. That is essential to boost your confidence. Okay, if you are sure that okay all the high weighted chapters are done, then you will be high on confidence and you can finish the low weighted chapter or medium weighted chapters later on. Use NCERT as base. NCERT should be your base. Okay, and also you have to practice numericals from the exercise of the NCERT textbook. Very, very important. Maintain an error notebook, even though it is not necessary for a PU board, but if you are maintaining a error notebook, that will help you in a long run. Not now, maybe not for your half yearly exam, but in the long run before your board exam, before your KCET exam, this will be very, very helpful. What is an error notebook? Error notebook is something where you note down the mistakes that you are making. Okay, suppose you are solving a numerical question and you are making a wrong formula, or you are understanding the concept incorrectly. So mention that what errors, what area you are making mistakes. Suppose you are not able to understand a certain concept, mention that concept properly, that I am not able to understand this concept. It will help you while revising. Just day before exam, you open your error notebook and you see, okay, these are my pain points, I have to look into it once more. So this is how you can revise the chapters quickly. Error notebook is a topper's secret. No one will tell you, but we are telling you so that you don't make mistakes in future. Now obviously sleep well. Sleeping well is very, very important. 8 hours sound sleep is essential. Minimum 6 hours of sleep and optimum 8 hours of sleep is good for you. And stay consistent. Do not break from your consistency. If you are studying say 8 hours every day, you have to maintain that 8 hours every day. So today you are thinking, okay, I have completed all the chapters, I will go and play for 8 hours or 6 hours. Do not do that. Consistency is very, very important. So staying consistent is the key to success. With this I will be concluding this lecture, and if you have any questions, any doubts, don't forget to mention that in the comment below, and whatever chapters I have not covered, also mention that in the comment section below, so that I can I have an idea. Also, if you have not yet subscribed to our channel, definitely subscribe to our channel and join our WhatsApp channel. The link of the WhatsApp channel given in the description of this video. I'll be back with all the chapters discussion very soon. Till then, bye.